In this video, we are going to talk about Gregory-Newton forward interpolation formula. It's the same thing as if you are writing Newton's polynomial in forward difference operator form. So first we shall write Newton's polynomial for two data points. One point is x0, y0. Another point is x1, y1. So here x0, y0, x1, y1, these are two data points and they make up an equally spaced data. That is, we have x0 and x1, y0, y1. Since this is an equally spaced data, so the difference between x1 and x0 will be age. If the first x value is x0, the next value would be x0 plus age. And the next value would be x0 plus 2h. Means every next value is obtained by adding age into the previous value. And you can see the difference now. x0 plus age minus x0 will be age. The same way the difference between x0 plus 2h minus x0 plus h, which is the previous value, x0 plus 2h minus x0 minus h is again h. So this is an equally spaced data set. So first value is x0, next value is x1, and you can see that x1 is x0 plus 1h. Next value is x2, and you can see that x2 is x0 plus 2h. So if we continue, we can write x3 as the next value, which would be x0 plus 3h. So for this reason, we call or write xn equal to x0 plus nh. So we have an equally spaced data containing 2 points x0, y0, x1, y1. Using these 2 points, we can write Newton's polynomial, and we know that for 2 points, the maximum degree of a polynomial is 1. So P1 of x is a0 plus a1 x minus x0. So P1 of x is a0 plus a1 into x minus x0. And you saw in previous videos that a0 was y0 and a1 was y1 minus y0 over x1 minus x0. So this is just Newton's polynomial of degree 1. What we have to do is we have to write this polynomial in forward difference operator form. So the only change that you will make is write a0 and a1 in forward difference operator form. We cannot change much about a0, so a0 is just y0, but let's look at a1. In numerator, you have y1 minus y0. We know the definition of the forward difference operator, so recalling that definition, y1 minus y0 can be written as forward y0. Remember, forward operator is defined like this. If you have forward operator acting on y3, so it jumps to the very next value, which is y4, and then calculates the difference with itself. So forward y0 can be written as the very next y value, which is y1, then difference with itself, which is y0. So here we have written y1 minus y0 as del y0 divided by, now we know that we are dealing with an equally spaced data. So for an equally spaced data, x0 is the first value, next value is x1, which is obtained by adding h into the previous value. So we write x1 equal to x0 plus 1 into h, or x0 plus just h. The same way, if we had x2, it would have been x0 plus 2h. x3 would have been x0 plus 3h. So back to writing a1 in forward difference operator form. y1 minus y0 is actually forward operator y0 divided by, now since our data is equally spaced, so x1 can be written as x0 plus h using this minus x0. Simplify it and you get a1 as forward y0 over h. So a1 is forward y0 over h and a0 is y0. So we will put this value of a0 and a1 in our Newton's polynomial here, p1 of x equal to a0 plus a1 into x minus x0, and we will have p1 of x equal to a0 is y0, a1 is forward y0 over h, x minus x0. So this is now Newton's polynomial in forward difference operator form, or it's also Gregory-Newton forward interpolation formula. So we have written Gregory-Newton forward interpolation formula for 2 points. For 2 points, the maximum degree of the polynomial was 1. So we wrote p1 of x. Let's write Gregory-Newton forward interpolation formula for 3 points now. x0, y0, x1, y1, x2, y2. And remember that this data is also equally spaced. First, we will write only the Newton's polynomial using these 3 points. So for 3 points, the maximum degree of a polynomial is p2 of x and Newton's polynomial is a0, a1, 1 degree factor. You are writing p2, so you stop at a2. 2 means 2 factors. One is the previous one and another is x minus x1. You will recall that a0 was y0, a1 was y1 minus y0 over x1 minus x0, and a2 was a bit complex expression which was x2 minus x0, y2 minus y1 over x2 minus x1 minus y1 minus y0 over x1 minus x0. So this is Newton's polynomial of degree 2. Now we are going to write this polynomial in forward difference operator form. So to write this Newton's polynomial in forward difference operator form, we only have to write a's like a0, a1, a2 in forward difference operator form. We have already seen that a0 is y0, y1 minus y0 is del y0. We have just seen here. a1 is del y0 over h. So it's the same. y1 minus y0 is del y0 over x1 is x0 plus h, since your data is equally spaced, minus x0. So x0 cancels with this x0 and you have del y0 over h. So we have a0 as in y0, a1 as in del y0 over h. Now we are writing a2 also in the form of forward difference operator. So a2 will be 1 by, since your data is equally spaced, x2 can be written as x0 plus 2h minus x0. Now y2 minus y1 in forward difference operator form is forward y1, because when you open forward operator y1, it is written as the very next value y2 minus y1 divided by x2 is x0 plus 2h minus x1 is x0 plus h minus y1 minus y0 in forward difference operator form is forward operator y0, because when you open forward operator y0, it gives you y1 minus y0 divided by x1. Since your data is equally spaced, x1 is x0 plus h minus x0. Let's simplify. So we have a2 is equal to 1 over 2h del y1 over x0 plus 2h minus x0 minus h minus del y0 over h. We have a2 is equal to 1 over 2h del y1 over h minus del y0 over h. So we are taking this 1 over h common out, and inside we have del y1 minus del y0. We can write a2 as 1 over 2h square. Let's open up del y1, which by definition of forward difference operator is y2 minus y1 minus forward y0 is y1 minus y0 by the definition of forward difference operator. So we have a2 as 1 over 2a square y2 minus 2y1 plus y0. So this is what we got for a2. Let's do some simple calculation on the side. Let's say you are asked to calculate forward difference operator applied 2 times on y0. So what you do is 1 del out and 1 del in. Del y0 by definition is y1 minus y0. Now just like you apply a number inside, the same way you apply this forward operator inside, multiply it with both y1 and y0. You have forward y1 minus forward y0. Forward y1 by definition is y2 minus y1 minus forward y0 by definition is y1 minus y0. We simplify it and get y2 minus 2y1 plus y0. So you can see that forward square y0 is equal to y2 minus 2y1 plus y0. Let's put this value of del square y0 here. So we have a2 written in more compact form, which is 1 over 2h square forward square y0. So what we are seeing here is a2 is forward square y0 over 2h square. Or we can also write a2 equal to forward square y0 over 2 factorial h square, because 2 factorial is 2 into 1. So no difference. Here we have written a2 in the form of forward difference operator. See, here we started with the definition of a2 written in this form. It was a lengthy expression, but now we have changed this a2 into the forward difference operator form. So what we have here is a0 is equal to y0, a1 is equal to forward y0 over h, means the power here is 1 because you are writing a1, and then a2 is forward square because you are writing a2 applied on y0 divided by 2 factorial h square. So we can see a pattern here for the 2-degree polynomial. Let's look at that. We needed the values of a0, a1, a2 written in forward difference operator form, and that's what we have found. But suppose you also needed to write a3 So looking at the pattern of A0, A1, A2, A3 will be forward operator power 3 on Y0 divided by 3 factorial h cube. So now we are ready to write Newton's polynomial in forward difference operator form. So it will be P2 of x, A0 is Y0, A1 is forward Y0 over h, x minus x0 plus forward square Y0 over h square 2 factorial x minus x0 x minus x1. So we have written Newton's polynomial but in forward difference operator form, and it is of degree 2, or it's the same as you have written Gregory-Newton forward interpolation formula for 3 points data. So first you just write Newton's polynomial, which involves a's, and then you convert that Newton's polynomial in forward difference operator form. So you just have to write A0, A1, A2 in the form of forward difference operator. In the next video, we are going to talk about backward difference operator, and then we will write Newton's polynomial in the form of backward difference operator.